Hi there. My name is Ruthvik. I'm a cloud data engineer. I build pipelines. I recently built a fully automated data pipeline on Google Cloud, which replaces manual ingestion, transformation, and scheduling. Today, I have decided to walk you through how I built my project using GCP, PySpark, Apache Kafka, and Apache Airflow. Let's get started. Well, this is the architecture of my data pipeline, where my pipeline begins here. The pipeline starts from here with the raw taxi CSV files which are stored in the Google Cloud storage, and all the unprocessed data will first land here. From here our pipeline starts. From here Airflow orchestrates the pipeline. It detects new files from the CSV files. It schedules a Dataproc job, and it manages or handles the workflow dependencies. And I have used Dataproc to handle my PySpark job, because I've tried to run locally on Windows, but I find it very difficult because Windows is not that user friendly. I mean, like Windows is not that friendly for a huge amount of data to run or initiate or implement a PySpark job. This Dataproc helps cleaning the data, transforming the data, partitioning the data, and also writes the clean set of data into the GCS processed zone. And this is a very good practice to write all the clean data set into the processed zone. From there, I have loaded the data into my BigQuery for analytics. The BigQuery app created partition and clustered tables, SQL models, and analytical views. Once the data is loaded, the Looker Studio visualizes the KPIs like revenue trends, trip density, and passenger patterns. Alongside the batch pipeline, I also built a streaming pipeline. The events were received by the Kafka, and the streaming was done using Spark structure streaming, which writes output to storage, and BigQuery with checkpointing. This gives me a complete modern data pipeline architecture: batch plus real time plus orchestration plus warehousing plus visualization. It's very similar to what companies run in production. Next, let's look at the raw zone in GCS. This is my bucket, and this is the big data.csv. This is where all unprocessed data is stored before any cleaning. And I upload files either manually or using a Python ingestion script. And over here, the Airflow monitors this bucket and automatically triggers the pipeline when a new raw file arrives. After the transformation, the cleaned and partitioned data lands in the processed zone. This separation between raw and the curated data is essential for governance and scalable analytics. Now let's move to the transformation layer. I've used Cloud Dataproc on Google Cloud to submit my PySpark jobs. Actually, there are two ways to submit PySpark job on Cloud Dataproc. You can use gcloud through command prompt, or you can use the Dataproc UI. In my case, the full job already completed earlier, and produced the processed partition data in GCS. Here is the PySpark script I built. It loads raw CSV files from GCS, applies schema enforcement, filters bad rows, standardizes timestamps, and also writes the output partition by year and month. Once the job completes, the processed data appears in the GCS processed zone. You can see the partition structure here. This is this clean and optimized data is what we load into BigQuery for analytics. Once after the job completes, Dataproc writes properly partitioned Parquet files back to GCS. These partitions help BigQuery scan only the required data, reducing cost and improving speed. This is where the FinOps concept comes place. Instead of running the entire data set, it's better to run the partitioned table for to get the required data. The next step comes in the pipeline is to loading the data into BigQuery. So here in BigQuery, I've created a data set called NYC Taxi Demo. This is where all the transformed PySpark output lands. This is the processed table, trips cleaned, which was created by my PySpark job. And also made sure the trips are partitioned by pickup date, which reduces query cost and improves the performance. So you can see partitioning column here. So here I am running a simple analytical query. Because the table is partitioned, BigQuery only scans the partition needed, making it fast and cost efficient. Finally, the BigQuery dataset powers my Looker Studio dashboard. All the charts, revenue trend, average distance, and trip count by pickup location are live and connected to this BigQuery table. Well, that completes the BigQuery analytical layer. Now let's move to the next step of the pipeline. Now let's look at how this entire pipeline is automated using Apache Airflow. This is my Airflow DAG, which orchestrates every stage of the taxi data pipeline, from ingestion to transformation to loading into BigQuery. If you see the sequence of tasks defined over here, each task corresponds to a specific part of the pipeline. This is my DAG Python file. I have defined DAG schedule, default arguments, and operators. So this is the DAG arguments. This is the DAG arguments. This ensures reliability. If something fails, Airflow retries automatically. And this lists GCS files. I've used GCS list objects operator. This operator connects to GCS to list all the raw files, and this defines the order of execution, how Airflow handles everything automatically. First it lists the files, then load to BigQuery, then runs PySpark, then publish to analytics. This is the procedure that Airflow follows. Let's say think of an Airflow as a traffic controller of the entire pipeline. It decides what runs next, what happens if something fails, and when each part of the pipeline should start. And that's how I use Airflow to automate, orchestrate, and schedule the entire data pipeline end to end. Now let's move into the real part of my pipeline using Kafka and Spark structured streaming. Well, this is the architecture I followed for my Kafka and Spark structured streaming. If you see here, this is the Kafka producer. This is the program that sends messages. Let's say think of it like someone throwing balls into a basket. And this topic is the basket. It stores messages until someone picks them up. And here comes the Kafka broker, and this is the server running Kafka. Basically does manage topics, partitions, offsets, and it works as a brain of the Kafka. From here, Spark continuously reads data and processes it and converts it into structured records. And this helps Spark remember where it left off, so it never reprocess old data, and that's called checkpointing. And finally, processed real-time data goes into the GCS and for BigQuery for analytics. And this is the same architecture was used by most of the big companies such as Uber, Lyft, and most of the applications which track live events. They also use the same architecture. In the next step, I will show you the actual Kafka setup, like creating topics, producing messages, and consuming them live. Now let's jump into the real-time part of the pipeline, which is Apache Kafka. This is where all the live events enter the system. And for that, first we have to start the Zookeeper. Let me enter into my Kafka directory. So this is where all the installations were done of mine. So first we have to get into that particular folder. From here, we have to start the Zookeeper, and we have to use this command to start the Zookeeper. Now that if you see the Zookeeper started running, so now you have to open the another terminal where you have to start the Kafka broker. We have to get into the same directory. Once after we get into the directory, and this is the command we use to start the Kafka broker. And if you see, the Kafka broker started running. After Kafka broker got started running, we have to create a topic. Next, I created Kafka topic called taxi events. For that, we have to open another terminal. First, we have to get into the directory. And this is the channel where all incoming live trip events will publish. First, we have to create a topic. And this is the command I used for creating a topic. And I am using a 3 partitions so messages can be parallelized, and more options equal to more throughput. That's how it works. Now, if you see, the topic C events are created. Now we have to open another terminal for producer. And over here, after getting into the directory, and this is the command we have to follow. Now you see the cursor over here. After executing this command, I will type I'll give some data. The data I given represents streaming trip events. These are very similar to what you would see from Lyft, Uber, or DoorDash in real time. Now, in a separate console, I will run a consumer that reads events as soon as they arrive. For that, we have to open another terminal and get into the directory. Once we enter into the directory, and this is the command. Once we push enter, yeah, this shows real-time streaming. The moment data is produced, it's consumed. If you see the messages over here, this shows the real-time streaming. The moment data is produced, it's consumed. This consumer is what Spark Structure Streaming listens to in the next step. Well, before we close, let me quickly summarize the pipeline end to end and the key engineering lessons, what I have learned building this project. The project has 2 major parts. One is a batch pipeline and the other one is a real-time streaming pipeline. We have used GCP, Dataproc, BigQuery, and Looker Studio for the batch pipeline, and Kafka and Spark Structure Streaming for the streaming pipeline. And also, this is the same architecture is used by the big companies such as Uber, DoorDash, Lyft to process their millions of events like orders, GPS location, driver's location, and so on. And while building this project, I've learned a lot, like how to design clean end-to-end pipelines, how to use PySpark scalable processing, how to orchestrate production level DAGs in Airflow, like how Kafka streams real-time events, mainly how to think like a data engineer, like not to just write code, and also how to solve distributed system issues for Kafka, Spark, Hadoop, GCS. So these are the things I've learned while performing or executing this project. Finally, thank you for watching the video. If you are a recruiter or engineer reviewing this video, feel free to check my GitHub, LinkedIn, and portfolio dashboard. I'm actively looking for data engineering roles. I would like to contribute to a real world team with these cloud and streaming skills. Thanks again. Thank you.